Hey everybody, here we are at our friend's house in Wichita, Kansas. We're here where Wes, Chris, and Aaron Bockley have a business of redoing buses and lifting the roofs and doing all kinds of cool stuff, which Jim will probably show some more of that in his video. But the reason we're here not only is to see some of our really great schooly friends, but also because our solar was not working just right, and so we brought it here for the expert to look at. And maybe you can see now what's happened. Everything's torn out. They're taking everything out, and the reason we had some inverters, and we actually even bought another inverter to go with our bus because we thought one of them wasn't working right. Anyway, the problem is that the inverters that we bought were really great, but no one seems to know anything about how to work on them or anything. So we're replacing everything in here with Victron, which is a very popular and well thought of solar system. So Aaron Bockley is helping us do all that, and he is Mr. Brainiac genius and knows what he's doing. And the main thing is it will be very safe and very reliable. He's putting this on some kind of a deal where he can even monitor it from his phone and let us know if there's something going on that shouldn't be going on. But I was just going to show you where we're staying in a really cool place down here, and we will let you watch some of the stuff that we're doing on our solar as it goes along. But right now Jim wanted to do some things to help our lovely friends out, because he has been working 24 hours a day, it seems. So he mowed their lawn for them, and there were a lot of weeds that had grown up down here, so much so that you couldn't see the river. So Jim has fixed it so now you can see the river. And we've been spending a lot of time sitting down here in this beautiful area. Isn't it fabulous? Oh my goodness, we just think it's just a lovely, lovely place. There was an old dead tree that was about to fall over right down in, I don't know how to point to it, but Jim's walking over there to it right now. And so Jim cut it down, and he's going to make them a little table height stump there that they can use for that. He's probably going to dig them a little fire pit here, and as you can see, they're right on the river. So we enjoy being around these kids and their children. I have 4 children, but Aaron is brilliant. If you ever need to talk to somebody about solar and get some information about it, some advice about what to do, or if you just need to have it reworked like we're doing, he is the guy to talk to. He's Mr. Smart on all that stuff. So he talks way above our heads, we know that, but it's a lovely spot here. So we don't know how long we're here. Next stop, Oklahoma, but we'll give you some more information as we're redoing and what's going on here. Love you all lots. Bye-bye.
Debbie.
Hi, baby.
So Debbie is cleaning up around our door. You can see I had to seal the door, and didn't have time to dig out the paint, so it's all brown, ucky looking. That's the caulk. And so Debbie's painting over that caulk so it looks a little better. Right, baby?
Right.
And down here.
For a while, and
it has. Time to fix it. It is. So here's Aaron and Debbie
yes.
Debbie's been cleaning. Oh, she looks like she's been
Sandy. My friend Sandy Edding.
cleaning windows.
She loves to clean windows, so.
So, look at this big old clean, wonderful hole we now have for all of our new components. Tore all the old stuff out, and we're rocking and rolling.
Out with the old.
Okay, this might be a fun video. Here's what we're gonna do. I'm gonna go through, oh, by the way, Aaron just completely redid all of our solar, so it's very exciting for us, but I'm just gonna go through and try to remember, try to tell you what all these things do. There's no way I'm gonna get it right. So on our big batteries, we have this little cord right here. It goes, this little cord right here goes to a fuse right here. A fuse, and then a charger. You can lift this up if you want, baby. Makes it kind of, sometimes you can. Oh, it's
Can you see it?
Yeah, but you've got to, okay, yeah. Point it right up here.
Okay, now there.
Okay, that box right there, what that does is that takes 12 volt from our battery and it sends it up and it charges our house batteries, which are, you can see them over there. There's 12 of them. So that's what this
when
does.
the car's running, when the
when
bus
it's
is
running and
okay.
going down the road. Okay, you can shut that off now. We'll go around.
Go ahead.
So I forgot to tell you, there's a breaker back there besides that little blue unit, and it's an actual breaker. It looks like this one, but it's not the same voltage. It's a higher voltage. Okay, then when we come up here, under here, we've got a.
You're gonna have to.
Well,
there you go. I see it.
under here we got a 50 amp breaker, and then also this is also in that same line for the battery to charge the house batteries from the generator. This is also a 30 amp fuse right there.
Okay.
Then we've got 12 batteries in here. They're AGMs, and you know, I don't know what their amp hours are, but they're heavy. They weigh 120 pounds a piece. Sometime in the future, not right away, we'll be changing to some lithium batteries because they have some advantages. Now this is the big wire that goes to, this wire right here is the big wire that goes to the other end of our battery bank. This one here is the negative that goes to this catty-cornered end of our battery bank. That way all the batteries are getting charged equally. Then this little block right here, this little little silver thing, if you can see that.
I can see it.
What I think that does is that charges, somehow that charges my my batteries when we're sitting still. The solar charges up these batteries, and this little thing charges up my start battery, so I don't have to put a charger on it when we sit for a while.
Okay.
Okay. This is a cool little thing. It has what? It has 24 volt and 12 volt banks in it. It looks a little bit like a Star Wars item.
Yeah.
And then up here, I don't know. That's where the power comes in. I have no idea. There's 3 cutoffs, but here's what I know. I know this one cuts off first. Then you cut the other 2 off.
Okay.
Now, if I have to work on my battery or anything, what I do is I push this red button right here.
Okay.
And it cuts off the breaker to all that back there.
To the battery.
Yeah,
okay.
to the battery.
Yeah.
That way I don't do something ugly.
That's really everything we need to know at this point.
Okay, that's about, let's see, what else? Oh, I know something. We just put this big honking, see that one right there? That big honking ground wire over to the frame.
Okay.
So we've got ground wires, I can't count them. There's more than I can count. But we've got a lot of them.
Yeah.
And I really can't tell you a lot more about this except all these blocks allows them to hook up all kinds of different stuff. And then up here, where you can't see it on the bottom of the floor,
maybe
up there.
you can
Okay,
stick that over there.
that right up there, that's a bunch of, I think, 150 amp breakers is what those are. I have no idea why. Anyway, let's go this direction. I'm almost done here.
You want to go in this in this little window up here?
Yeah. Okay, you're caught.
I am.
Are you still recording?
Yes.
I have to cut that
You'll
out.
have to cut that out. Yeah.
Okay, now this is a very unique system. You're gonna love it. Okay, over here are my house breakers for all my different circuits.
Okay.
And there's actually room left to put more. Victron, the main thing I can say about this is it's way heavier than my old ones. Like my old ones are probably about 10 pounds. These are probably, I don't know, 70 pounds. They're biggies. And they're smart. That's the other thing.
And it's 3,000 watt.
3,000 watt inverters. And then this is a charge controller up here. I can tell you about that. It's expensive.
Well,
and so are
everything
these.
is.
Other than that, it's a charge controller. And this is for 20, yeah, mine are
24 volts.
24, 22, whatever it takes, 23 and a half, 24 volt charger. This one, I love this one here. Let me see if I can figure out how to open it. This is our solar break. I don't know how to open it. Okay, it's our solar breakers in there.
Yes, okay.
It's got a big main one right there, and then it's got a bunch of actual fuses in it, which is so cool.
Alrighty.
Yeah, and it just flips open and you replace the fuse if you ever need to. I'll never need to.
Yeah.
But the most unique part about this entire system is our ground.
Yes.
I told you there's a lot of grounds. Here's a very special ground. This copper wire goes down into the earth.
So it's the earth ground.
It's the earth ground.
It's the real ground.
It's the real ground right there.
And these wires go into there, which is actually my kitchen cabinet, right?
And this is right here is where we change from the wires coming down from the solar, and he's got a deal in there, and then coming out of that are the ones that go up into this solar. Yeah. Right here. Pretty cool. It's
right
cute.
There. Yep. What you doing, Jim?
Well, I'm fixing a electrical plug. Putting in some new wire for an electrical plug. This is something that my friend Aaron Bockley wanted to do, so you know what? We're gonna get her done.
Yep, you're doing as much of it as you can. Here's some of the bits and pieces, as
he
calls it, under here. And here's the new inverters. They are for anyone that's interested and understands this stuff. We have two 24 volt, is that right? 24 amp. 24, what do you call it? Volt or amp? Amp.
I'm not doing that video.
24 volt, yeah, and 70 amp. 3,000 watt, 24 volt, and 70 amp. So you can have a 12 volt system, 24 volt system, 48 volt system. Ours has always been 24. So we kept 24 volt, 3,000 to 3,000 watt inverters, and this is all Victron stuff. So everybody should, you know, wherever we go, should be able to figure out if there's any kind of problem with it. Okay, now
here's where our wire comes in from the battery bank and the fuses and all the stuff back there. Comes in right here. There used to be another block here, but it's gone. But it comes from over here, and that's where it picks up its power, because that's our main bus battery power deal right there. So it picks up its power and it feeds back for, I think it's some kind of a sensor or telling us what something's doing. Okay, come on around here. Okay, so we have a little screen right here. If you take a look at that, and that has little dots that are traveling on these little blue lines, and they're straight lines. They're blue lines. It's showing where the juice is coming from, where it's going, how much it's using, how much you're getting from solar, how much you're getting from your batteries. It's a lot to learn. I will eventually learn it, but that tells me what all's going on.
Yeah.
Now also, he put new wire to our sea levels.
Yeah.
So this sea level will tell me 13.5 is what it says is in my battery.
On the start battery.
Right now. Fresh water's at 50 gallons. Isn't that cool? So we got new wires to all this, so now you can see exactly what's going on and what's in there.
Okay. And who did this for you?
Oh, my very good friend Aaron.
Aaron Bockley.
Aaron Bockley of Broccoli Bus.
Broccoli Bus 6, I think, is their name
6.
on Instagram.
And he is so good at this. But
he's going to tell you a little bit about it too. Oh, also he can monitor our stuff from his phone.
From his phone. And we can monitor our stuff from our own phones too.
Yes.
So that's it.
Yeah.
I'm excited. It's working. It's cooking. So now I'm going to let Aaron actually tell you what this does.
Yes. Okay.
That was my guess.
Okay.
Well, Aaron, we're getting close.
Yes, we are.
Well, my friend Aaron almost has all of the electric side, like the shore power side, all hooked up. That is amazing. The service side.
Hi.
And he's a genius.
I play one on TV, maybe. I stayed at a Holiday Inn Express once. My wife hates me saying that. I do have experience putting these together. I've put together a lot of vehicles now with various power systems. And a long time ago, I used to work building boats occasionally for a few years. That was really interesting. And I've just messed with electrical and all sorts of stuff. And so this is kind of my fun thing, happy place to be at. So I guess we're going to explain all the stuff that changed on Jim and Debbie's vehicle here. And I know that Jim did an explanation, so I kind of was an earshot. I'm going to try to cover the same systems and explain how I think I've put them together and how they're supposed to work. So Jim, this is for your documentation purposes too, so you can remember how things go.
Awesome.
So we'll start over here. All right, so to start with, we'll just look at this little blue box here. This is a vehicle charging controller for taking power from the alternator and putting it into the house batteries. And what this does is it's called a boost converter, and it turns the 12 volts into 24 volts because their house batteries are 24 volt. It has a little computer in it and a little Bluetooth thing to program it, so it will detect when the engine's running and when it's not running. So it only charges when the engine is on and presumably the alternator is turning. So it can put up to 350 watts of power into the battery bank, the house battery, taken from the alternator. So we'll kind of...
And there is a new part.
Oh yeah, we added a breaker to it this time around instead of a little fuse. Here, I can maybe hold that camera back there for you. So there's a little breaker button right there. So that's a 60 amp breaker for the size of the wire we've got going on here. So we go mosey on back to the start batteries here. Here is your connector for your positive and then your negative for that charge controller. Maybe it's this one actually. So Jim, keep your battery terminals clean, brush your teeth once in a while.
Okay.
Greased with a little bit of that dielectric grease, and look for corrosion, and you got to check your water on your batteries.
Okay.
This is more important now than before because we have active charging on this stuff going on all the time. So that's my note to Jim. Yeah, we can take a peek right now. Yeah, a couple of them seem okay.
That one's got water in it.
Yeah, we won't check them all right now. We'll check them the rest later here.
Okay.
So hopefully you don't have to hang this charger off of here anymore, and just keep the door closed, and it always works.
Oh, isn't that great?
I think it is. That's for sure. So we'll go around this side.
Now we're getting to the serious stuff over here.
So we updated your plug from a 30 amp short plug to a 50 amp short plug. So we have the little twist-a-lock guy, and there it is there. And set that there for now. And let's go under here, and I will attempt to explain. I'll just kneel on this thing because it seems comfortable. So we'll talk about the AC side of things first. So this is your master breaker, 50 amp 2-pole breaker from your shore power inlet. If you shut this off, everything downstream that comes from the shore power is disconnected. It goes up into the box up above. We'll talk about that in a minute. There's your existing 24 volt battery bank. It's based on telecom batteries, which have an interesting property of low discharge rate for what they are, but high capacity. They can go discharge deeply. So you have a 2x6, two in series, 6 in parallel battery array. We move these cables to the far end. You'll see that they're double cables, and what they do is they connect into these 2 disconnects, and then they go to these 2 bus bars, and then there's a bus bar interconnect. This gives you the ability to balance the current draw and return from both charging and discharging on this circuit. You have to usually keep this thing turned on to make a loop for this back here, because it's using it to balance that. We could have used one big giant cable, but we didn't have one big giant cable, so we went with those instead. And actually we get a little more cross section out of these 2-watt cables than we do out of a single 4-watt with this stuff. Same side for the ground. You see there's 2 wires hanging from the ground cable right here, and by splitting them up evenly, these are all exactly the same length, within a millimeter or so, they go to a single terminal point. And then we have your battery shunt. This is the current, this is the column counter. This is looking at the differential voltage between a calibrated resistor right here, and then there's a little computer that tells us how many amps are going in and out, because the voltages will change direction, and also measures our voltage. There's 2 wires in here. One of these wires is measuring the voltage of the battery bank, kind of at a center point. Or I'm sorry, yeah, voltage. And then this one is going up and connects to a wire that's measuring the voltage of your start battery for your bus. So you have that in your computer all the time to show that information. Let's see, what else is going on in here? We have this wire here, which was the desert installation that we did for that alternator charger. So these wires are a bit smaller because it's 24 volt on this side, so they feed into the terminal blocks here. There's an inline 30 amp fuse right here to protect it on this side. These then feed into, there's some big cables here. These guys go up to the inverters up above, which we'll look at in a moment. This one here is the ones that feed from the battery to the main disconnect. So we can, if you disconnect your, I have an instruction sheet for you, so I'm usually not great at explaining on a camera all at once, but to disconnect one of the inverters or to power it off, you would disconnect your interconnection, and then you would be able to turn off one inverter or the other inverter. This breaker in the middle is for your 24 to 12 volt converter, which we'll talk about in a moment here too. So other things that feed in here, let's look, what do we got? A couple grounds. So let's talk about the ground. So this particular ground is important. You did not have a bonding ground to the vehicle chassis before, and so this is a very large bonding ground to be able to connect to the chassis. So anytime we're playing with converters that convert 24 to 12, or using a reference ground for the inverters and safety the chassis safety and the case grounding and all that stuff. When you're making power, you need to have a big enough path to ground to be able to trip the breakers and basically protect yourself if there's some sort of fault on the high voltage 120 volt or 240 volt side of things. So this provides that ground reference that is critical safety cable right here. Let's talk about this brick for a minute. So we have a split bus power bus panel here. So we have on this side we have 12 volts, and on this side, the B side, we have 24 volts, and these are just standard ATO fuses in here. I just put some extra fuses in there, but really we have this 125 amp fuse here. Then we have your shared ground, and then your so this is your 12 or your 24 volt side down here. So we have a 30 amp breaker protecting everything on the 24 volt side, and then we have a couple of cables here that come from the 12 volt side. So the output is on a 25 amp fuse on the 24 volt side, goes to your buck converter and turns it to 13.8 volts, and then this feeds the 12 volt side of the panel here. And then these two big cables, which you pulled these through the frame rails, and you were really greasy when you were done.
I was greasy.
Yeah, these are a little oversized for the size that we put fuses in needed, but that's perfectly fine because we had that cable, and it's really good welding cable, and it's fine. It was a little challenging to fit the terminals on the ends of it inside of there, but we all made it work. So this feeds up to the front electrical box, which we'll look at in a moment, and then you can see that this is grounded to our primary grounding bus bars and kind of back into everything there. If you want to turn off this panel entirely, including the 12 volt side, just push this breaker button right here, and that will disconnect this power brick. It will no longer be energized, creating 12 volts or 13.8, and it will de-energize any 24 volt things that are connected to this panel. And so you just reconnect it like that.
Awesome.
So, oh, and there's the two little screws in the side of this if you ever lose one of these when you're putting something in. It's kind of a nice little thing that Blue Sea does with those. So we'll put that back on there. What else is down here? There's a couple little inline fuses for things. So each of these has an inline fuse for the little computer. I'll wait for that motorcycle to go by. So you have some inline fuses for each of the little consumers that come off of here. So there's one of these is for the computer that coordinates everything, and then every battery sensor has an inline fuse in it too. So if one of those ever drop out, it's because the fuse might have broke or something like that. That protects that wiring.
And there's some big breakers up there.
Yeah, so up here we have I believe this is a 100 amp breaker, and then we have this is for the solar charge controller, and then these are 150 amp, or I'm sorry, they're fuses, not breakers. 100 amp fuse, and then a 150 and 150 amp fuse for the two inverters. So the inverters are fused at this point. This last block here is unused. There's no fuse in it. Okay. So future expansion, I don't know, that kind of thing. We had 4 fuse holders, so we put them in. And then you'll see that there's 2 holes going up in here. This is just for all the power feed in. One of the important things here is that your shore power comes into this box, and this is where all of the neutrals, earths, and the 2 legs are coordinated inside of here to feed the inverter. So each of these blue lines feeds one leg and then the other leg of your inverter system. So we'll talk about that next. Oh, let's get up. Put this cozy little pad back in here.
Ready?
We're ready. Okay, so there's quite a few things going in here. We'll continue talking about the AC distribution side of things first. So the power comes from that big master 50 amp breaker for the shore power. Gets appropriately split up into neutrals and earths and a hot leg for each of these inverters. So these are called multi+2. They do have the capability to pass the second leg through them, but we're not using that feature. We're simply feeding one leg of 120 volts into this one and one leg of 120 volts into this one. They are connected together via a data cable. It's just a standard Ethernet cable, Cat5, Cat6 cable, and I think it's 3 feet long. And what it does is this cable shares information for these two things. They talk to each other and they're programmed to know each other. So they are coordinated and act as the split phasing for North American 240 volt split phase power. So this one's putting on 120 volts and this one is too. And they feed into the second blue conduits that feed into the electrical panel. Your electrical panel has a master 50 amp in feed right here. This in this position, and then you have a bunch of little split circuits here. I probably could have put these all on larger single breakers instead of this, but it just kind of made sense with the way your wiring was. This one single 20 right here, that's your air conditioner. And then I haven't labeled all the other ones, so I'm a bad electrician. We'll have to figure out how to label those. Around the corner, inside of here, we have a couple really important grounds. So this one is your solar photovoltaic lightning discharge protector. It's not going to protect you of a lightning strike. What it does is it constantly is there to de-energize the electrostatic charge that is built up when you're underneath lightning. So this is really important to keep there. This bigger lug here is the primary earth for the entire panel. So if you look, this is one of your old cables that we use. I think it was a chunk of your old battery cable that you were using, that really stiff wire, and it goes into the electrical panel and connects to the earth bond. So that's your primary earth bond between your panel and all of the alternating current and some of the photovoltaic grounds that you have, earths that you have in here.
Now there's another earth ground.
Oh yes, then we have this additional earth bond. This one's the most important one, I think, actually, because it's Kansas earth. And you'll always stay grounded by having this little bag of dirt connected to your, you know, like you have on your house, you got the grounding rod outside. It's like a little tiny portable version of it. So.
And it's for looks.
And it also looks pretty cool, I think. If you direct the camera back at these green wires, each of these are the bonds that you have. So these are bonded together. They're bonded to the panel. The panel's bonded to the big lug. And then if you, yep, that guy there, and then that over here, spin the camera this way. One of these is the panel interface to the roof, the photovoltaic interface, and the other one is the solar charge controller, also has its bond. So all of the case bonding for everything is tied together to the skin of the bus. Inside of here is your photovoltaic disconnect. So some important things to consider. These are your fuses for all 4 strings of panels you have on your roof. Never ever ever open these up under any kind of load. So if it's sunny out and you're getting any charge, do not ever open these. You could get a big arc flash on these. Use the switch first and then shut it off to remove any loads. Then you can change if you have to do something. If one of these pops a fuse, there's something wrong with your system and you need to have some investigation before you just throw another fuse in it too. But this little box is just something off of Amazon with some rated components to be able to pull the power in. It's a great little easy button for combining solar at this size together. Let's see. This block right here is what's called Victron's, what they call the Venus OS device. It's actually a little embedded computer. It's got a computer screen, it has network and Wi-Fi and Bluetooth and a whole bunch of plugins for everything. So these inverters talk to this, the solar charger talks to this, the battery shunt talks to this, your temperature sensors, and then if you had different sort of sensors, you could add like tank levels and all sorts of other things to this if you wanted to. If you ever had a propane sensor, we could hook a propane level sensor to it, that kind of stuff. This is how this thing talks to your Starlink, and then Starlink records the information of all the stuff that's going on and saves that on the cloud. And so as long as you have an internet connection, I've set up some various alarms and warnings and things if parameters go out of what they're supposed to be, and they should message you guys and they'll message me as well, so I'll know what's going on. I'm not sitting there staring at the screen all the time. I've got something else telling me to do stuff, what's going on. And then, let's see. Oh, and there's a GPS antenna here. So if you need to do something incognito, just unplug the GPS, I guess. But what it really does help you with is it sets the time correctly for the system all the time. And I have some rules set up to try to get the battery charged properly depending on time of day. So there's a little bit of custom magic that I threw in the background. On the Victron components, you can add a tool called Node-RED, which is a visual programming language that I put in there. You guys don't need to know how this all works. I just set it up to just make it work. But what I've done is change some charge curves that kind of help keep make sure that your bus is as greedy as possible for power early before getting to the end of its solar cycle for the day. If we come over to this side over here, this is a mostly water resistant box that we put in that took your existing wiring from the roof. We've tried to put it through some nice gland nuts and stuff, and then you put this very stylish, looks like a Sterlite container trimmed down a little bit to cover the wires. And then this is the bond from this side, because on one of your previous videos that I had to do some research for, I found you taking the ground conductor and connecting it to the solar panel frames, and I think that you did that well by using the right, use that stainless to copper to aluminum frame thing. And we didn't want to just leave those floating, so inside of this box is a terminal strip that bonds all of those frames together separately from the grounds for this solar the panel itself, and then goes to this bond, and it bonds back to the panel just like everything else does. The positives and negatives convert from the cabling that you have into rated photovoltaic cabling of the right size, and then those connect into these MC4 connectors on this side. They just dip under and come around, and each of these, there's little labels on them that show which array is which. These are what are then combined in the combiner box.
Awesome.
I think that's kind of everything that's going on. Oh, that's the solar charge controller. So we can see it's got a little light. It's trying to charge bulk right now because you're not plugged in and it's kind of in the shade, but whatever. This is the data connector that talks to the servo. This is actually what's called a terminating resistor, because this is on a CAN bus interface, and so there's another terminating resistor there. And then we have our wires going into it. So we got the power, the charger out, and then the solar in over here. Not much else to say about that other than it sits there and that's what takes all that solar and turns it into DC voltage for your battery system.
Which is what we want.
Which is what you want. Let's go up to the front.
Okay.
All right, so we did a few things in here. We started by removing mystery wires, because you had mystery wires, and these were all connected to various unfused side of your bus bars in here, which worried me slightly. I mean, you've been fine for years, but you know how it is. You just don't want those. And I think because of the color on these, the pinks and the reds and the yellows, these are part of the old school bus door alarm system. So these were the things that actually went when a bad kid would open the door when driving down the road, and it would actually prevent the bus from starting. So you've kind of capped all that stuff off on the other end, and we're just gonna roll it up and tuck it in the corner and hope it's fine. We fixed some other grounds in here. There's still some mystery wires and stuff that I'm like, eh. Oh, hey, look, we can fix this one right now. Let's see here. We'll take that off of there. Take this off of there. Look at all this crazy stuff we can take off of here. I think I need a pliers. There you go. So you're going to come back next summer, and we're going to fix all this stuff up, Jim. There we go. Whatever that is, it's got one less thing on it. We don't need these things. So what we added was those two big red wires you pulled up front. We marked one of those as negative and one as positive. The negative we added is an additional big, you can see here, this big screw terminal, a bond for the DC charger side. So this is the ground, and then we got our power over on this side. This is a 40 amp fuse, because that little power brick can put out 40 amps at 13.8 volts. And then it goes over to here to the unswitched side of your bus power system. So there's the bulkhead connector, and this big cable on this side connects to your battery way back at the back. You have hooked up your diesel furnace and other things, and like your Bigfoot, your leveling system, all are plugged into this system somewhere. And in order to power those over time, you need to just like hang that battery charger off of there. And so now what this is going to do is this is a current limited constant volt battery charger. So what this means is that it will supply up to 40 amps. If it goes beyond, if it wants to demand more than that, it'll either, the fuse is going to break, or the charger will just descend in voltage to just make what it can. It will cut out eventually because it's protected. But the point is that this will supply most of the power needed to power the start battery side of any of your electricals that you have in your bus. So hopefully you're not running out in your jammies in the middle of December and hooking that thing up to get your diesel furnace going before, you know how that is. So,
my feet, thank you.
Yeah, so, and that's basically what we did up here. I guess the last thing was, you want to show the display screen inside the bus?
Sure.
Okay, we'll go in there. Okay, so the last bit is we switched out. I don't know if you ever made a video on it or said anything about it, but we had that little other battery shunt that you put in back in the desert there with your other system. It was just sort of a standalone thing, but you mounted it right here because it seemed like a good spot. We took that same spot and put this in its place instead. So what you can see here is those start battery was pretty low. We're actually still pushing 300 watts into the battery right now to get it charged back up. And then this is sort of the current power flow. We're only getting 90 watts of solar because we're getting complete shade in the late afternoon. I believe that this spot here is Debbie's command center right here. She likes to reach over here and touch on this thing and see what's going on, and you can go into the different menus and I don't know if I can.
And she wakes up in the middle of the night,
yeah,
and checks it out on her phone.
Yep, so this is really cool. You can set all this stuff and see what's going on, and basically it's just kind of a good place to see what's happening. I noticed you guys added this little countertop thing, which is really cool. It's a countertop extension and it kind of protects it from water spilling on it. I will say these are water resistant because the Victron intends these to be installed in boats and stuff like that. But I think it's smart to put this on here. You never know if you drop something and gets it all gooey, and it also protects your dimmer switches too, which I think is a good idea. So, yeah. So there you go.
Aaron, thank you so much.
Yeah,
you're such a blessing.
It was really fun. I enjoyed putting this new system in for you.
And I hope you guys enjoyed this video. So if you ever need work done, call me. You can get a hold of Aaron.
I'm in Kansas. Drive out here. We'll figure it out. So, yeah. Nice to. Bye.